Okay guys, today we're going to do the density determination lab. It's on Schoology. If you haven't found it, it looks like this. Has the equations on it, and in case you don't know what a beaker or a graduated cylinder is, I also show you pictures of those. And the second page is the data table, which you will need to fill out with units. Mass is in grams, volume is in milliliters. Once we get all the mass and volume data table parts filled in, then we'll take some time and we'll calculate the density of water, the density of nails, and the density of an unknown solid. So going back to the procedure, the density of water. It says measure the mass of a 250 milliliter beaker. Here's our beaker. We're putting it on the scale, and you should record your mass of your beaker as follows. Exactly what's shown on the balance. So make sure you record that mass in your data table. This is your mass of your beaker. Now it says to add exactly 50 grams of water. So I have a graduated cylinder with water, and I'm going to tare the balance. Tare the balance means this button right here, the 0 button. Where are your shorts? So now my balance is recording at 0, so now I can add my 50 grams of water. I'm slowly adding it. Now I'm close. So close. So now this is called a disposable pipette. I am going to add some drops of water because I'm very close. All right. It's close enough. It's 50.01 grams. So you added exactly 50.01 grams. So make sure you make a note that we added 50.01 grams. If you want, I can, you know what, let me just try to get, I don't know if I'll be able to get it at 50, but I'll try. There. That probably makes you happier, right? So we'll leave it at exactly 50 grams. See, you can record 50 or 50.01. This is what lab work is all about. It's iffy, give and take some. So now what I'm going to do is pour this may be hard to see. I'm pouring my exactly 50 grams of water into my graduated cylinder. But it's going to be hard for you guys to see the reading. So what I'm going to do is get a piece of paper. See if that helps. It does if my camera was upright. All right. So that is my reading. It's hard to see, but you have a little bubble there. I'm going to turn it a little bit so you can see the graduations. If you notice, this is a 100 milliliter graduated cylinder, and the graduations are by ones. So you're going to record your volume from the bottom of the meniscus. I will not tell you what that volume is. You have to read. So I think by now everyone has the volume. Make sure you record this in your data table. Or it might be easier if you want to just write things down and then move it in the data table later. So this is your volume. So far, we had a beaker that weighed 91.91 grams. We had 50 grams of water, and now we have this volume. All right. When you are recording volumes, you should make sure your volumes are always to 1 decimal place. You should make sure your volumes are always to 1 decimal place. Oops, it's upside down. Well, I think this is better than all the lag time, so that's why I'm doing it this way. So it's very easy to see when I put paper up. This is your volume. So mass should be in 2 decimal places with the unit gram after it. Volume should be with 1 decimal place with milliliters after it. If you're having trouble with this one, we know exactly that we have like 51, 52, 53, 54, 55 milliliters. But when you're taking a measuring volume, you're always estimating one. So we know we have at least 51, 52, 53, but then we have to guess the decimal place. Sometimes the decimal place is 0.0, sometimes it's 0.1, sometimes it's 0.2, sometimes it's 0.8. It all depends. You might have a different decimal place than someone else because it's a guess. That decimal place is a guess when you're taking measurements. All right. So now, that is all for part A for right now. We have the mass of the beaker. We have the mass of the water. You can put an X through mass of beaker plus water. You have your volume of your water. And now we're going to calculate the density later, but we're going to move on to part B. So part B, it says, obtain a couple zinc screws. So I'm going to zero my scale. See my zinc screws? I'm going to just, doesn't matter how many. I'm going to put this many. You need to get the mass. We're on part B now. We're getting the mass of the zinc screws. The mass of the zinc screws. Make sure you record it. This is part B. It might say nails in your data table, but we're getting the mass of the zinc screws in part B. Make sure you take it to 2 decimal places and make sure you put a label after it. The next thing we have to do is put some water in a graduated cylinder, and we're going to take a reading. All right. So we're going to take a reading off this graduated cylinder, and I know it's hard to see right now. We'll fix that. So this is your graduated cylinder. Take a good look at it. Count your lines. Make sure you take it to 1 decimal place. If the bottom of the meniscus is right on a line, then it would be a 0.0. If it's a little bit above the line, you have to guesstimate. Is it a 0.2? Is it a 0.3? Is it a 0.6? Remember, that decimal place is a guess, so don't be afraid to guess a number. Record this volume down in part B. So we're on part B, number 2. Oops, sorry, this keeps on falling. I'm getting a new camera today, guys. I'm excited. So you're recording for part B the volume of water. All right, the next thing it tells us to do is carefully add the screws. Now, I always tilt the graduated cylinder so they don't slam at the bottom. Okay, now we have a second volume to record. We're using water displacement to figure out what the volume of the screws are. Let me move it so you can see it a little bit. Ah, that's awesome. So record this volume. This is the volume after we added the screws. There you go. Awesome. The volume after we added the screws. Make sure you use a unit and you record it to 1 decimal place. All right, we are done with part B. You should have a mass of your nails, and you should have the volume without the nails and the volume with the nails or screws. All right, you might have to do some subtraction to figure out the volume of just the nails, just like we did yesterday in the PowerPoint looking at the rock. All right, the next thing we're doing, we're going to do part C. And this is where everybody has different ones. And I'm going to tell you who's what. So for this one, it's done the same way as the screws. You're going to take an initial volume reading. Okay, here's our initial volume reading. This is for part C. Let me move it a little bit. This is like, I wonder how we can. Oh. For part C, the beginning water. Part C. You know what? I think I'm going to end it here. I think I'm going to try to do part C live. All right. If not, I'll make another video. But for period 1, I'm going to try to do a live. All right. Hope this helps.